Our sun is a star, a giant ball of hot gas. It is the most important source of energy for life on Earth. It's mostly composed of hydrogen and helium, the two lightest and most abundant elements in the universe. The sun is incredibly hot, with a core temperature reaching millions of degrees Celsius. This intense heat is what drives the processes that make the sun shine. This immense heat is generated by nuclear fusion, a process where hydrogen atoms are fused together to form helium. Deep inside the sun's core, hydrogen atoms are constantly colliding at extremely high speeds. These collisions are so powerful that they overcome the repulsive forces between the positively charged protons, allowing them to fuse together and form helium. This fusion process releases an enormous amount of energy in the form of light and heat, which powers the sun and provides the energy necessary for life on Earth. The sun is about halfway through its life as a main sequence star, a phase that lasts for billions of years. During this stable phase, the sun steadily fuses hydrogen into helium in its core, maintaining a delicate balance between gravitational forces and the outward pressure from fusion reactions. But this stability won't last forever. The sun is constantly consuming its hydrogen fuel, and eventually, it will run out. In billions of years, the sun's hydrogen fuel will begin to deplete, leading to significant changes in its structure and behavior. This will trigger a series of dramatic changes that will have profound consequences for our solar system, including Earth. The sun will expand into a red giant, engulfing the inner planets, and eventually shed its outer layers, leaving behind a dense core known as a white dwarf.
Nuclear fusion is the engine that drives the sun, powering it for billions of years. It's the process of combining lighter atomic nuclei like hydrogen into heavier ones like helium. This fusion process is fundamental to the sun's ability to produce energy. This releases tremendous amounts of energy as a small amount of mass is converted into energy according to Einstein's famous equation E equals mx squared. This principle explains how the sun can emit such vast amounts of energy continuously. The sun's core is a chaotic and energetic place where temperatures reach millions of degrees and pressures are immense. The intense pressure and heat create the perfect conditions for hydrogen fusion to occur. Without these extreme conditions, the fusion process would not be possible. Every second, millions of tons of hydrogen are converted into helium within the sun's core. This conversion releases energy that travels from the core to the surface and then radiates out into space. This process of hydrogen fusion is what keeps the sun shining and provides the energy necessary for life on Earth. The sunlight that reaches our planet is a direct result of these fusion reactions. But like any fire, the sun needs fuel to keep burning. Over billions of years, the sun will gradually consume its hydrogen fuel, eventually leading to changes in its structure and energy output.
The sun has a finite amount of hydrogen fuel. As the sun continues to burn through its hydrogen reserves, it gradually converts hydrogen into helium in its core. This process, while slow, is inexorable. Over billions of years, the balance of power within the sun will begin to shift. As hydrogen is depleted in the core, the fusion process will become less efficient. The outward pressure generated by fusion will begin to decrease, while the inward pull of gravity will remain constant. This imbalance of forces marks the beginning of the sun's transformation into a red giant, a dramatic event that will reshape our solar system.
As the sun's core runs low on hydrogen, its outer layers will begin to cool and expand outward. The sun will swell in size, engulfing the orbits of Mercury and Venus. During this red giant phase, the sun will become a much cooler star. Its surface temperature will drop, and its color will shift to a reddish hue. Despite this cooling, the sun's luminosity will increase dramatically. This means it will emit far more energy. The increased energy output from the red giant sun will have catastrophic consequences for Earth. Our planet will be bathed in intense heat and radiation, making it uninhabitable for life as we know it.
Section 5. Earth's Fate. A Scorched and Inhospitable World. The expansion of the sun into a red giant will have a devastating impact on Earth. The once life-sustaining planet will be transformed into a scorched and lifeless world, As the sun swells, its outer layers will extend beyond Earth's orbit. The intense heat will boil away our oceans, leaving behind a barren and dry landscape. The atmosphere will be stripped away by the solar wind, leaving the surface exposed to the harsh radiation of space. Earth's once vibrant ecosystems will be eradicated, leaving behind a silent and desolate planet. The transformation of the sun into a red giant will mark the end of Earth's habitable period.
Section 6. Seeking Refuge. The Search for a New Home. Faced with the inevitable demise of our planet, humanity's only hope for survival lies in finding a new home among the stars. The search for a new home will require us to venture beyond our familiar solar system. We need to look to other stars and their planetary systems. These systems, known as exoplanetary systems, offer the potential for finding worlds that could support human life. Exoplanets come in a wide variety of sizes and compositions, offering a diverse range of potential candidates for our future home. The search for a new Earth is a daunting but essential task for the survival of our species. Section 7. Mars, a potential outpost. While the search for a new Earth continues, Mars represents a potential stepping stone for humanity's future in space. Mars is a cold and arid planet, but it holds some promise for human habitation. Its proximity to Earth makes it a more accessible destination for manned missions. With advancements in technology, it may be possible to terraform Mars, transforming its environment to make it more suitable for human life. Establishing a permanent human presence on Mars could serve as a crucial first step in our journey to the stars, providing a base for further exploration and scientific discovery.
Section 8. Beyond the Solar System. Exoplanets and the Future of Humanity. Looking beyond our solar system, the discovery of thousands of exoplanets has ignited the possibility of finding worlds that could support human life. Exoplanets are planets that orbit stars other than our Sun. Some of these exoplanets reside within the habitable zones of their stars, where conditions might be just right for liquid water to exist on their surfaces, a crucial ingredient for life as we know it. The search for habitable exoplanets is one of the most exciting frontiers in astronomy and astrobiology. Finding and potentially colonizing these distant worlds could ensure the long-term survival of humanity. Section 9. The importance of space exploration for survival. The impending transformation of the Sun into a red giant underscores the importance of space exploration for the survival of our species. It's no longer a matter of curiosity, but a necessity. Investing in space exploration is an investment in our future. It allows us to develop new technologies, expand our understanding of the universe, and search for new homes beyond Earth. Space exploration fosters innovation, inspires future generations, and reminds us of the fragility of our own planet and the importance of seeking solutions beyond our current limitations.
Section 10. Conclusion. The Sun's Legacy and Humanity's Future. The Sun, the lifeblood of our solar system, has been burning brightly for over 4.6 billion years, providing the energy necessary for life on Earth. However, like all stars, it will one day reach the end of its current life cycle, transitioning through phases that will ultimately lead to its transformation into a red giant. This event, billions of years in the future, will mark a significant turning point for our solar system. The Sun's expansion will have profound consequences for Earth and its inhabitants, potentially rendering our planet uninhabitable. Yet, the Sun's eventual demise also serves as a powerful reminder of the importance of space exploration. It underscores the necessity for humanity to look beyond our home planet. The search for new homes among the stars becomes not just a scientific endeavor, but a crucial step for the survival of our species. It's a call to action, urging us to push the boundaries of science and technology, to explore the cosmos with renewed vigor and determination. By advancing our capabilities in space travel and colonization, we can ensure the long-term survival of humanity. Even as our sun ages and changes, the Sun's legacy, in the end, may be to propel us beyond our cradle, encouraging us to seek out new frontiers and expand our horizons. As we venture into the vast expanse of the universe, we may discover new worlds, new possibilities, and new ways of living. These new worlds could offer fresh opportunities for growth, innovation, and the continuation of our species. The future for humanity among the stars is not just a dream, but a potential reality, driven by our quest for knowledge and survival.